The broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning, everybody. And this is Dr. Mansour, and today is the 5th of April, 2020. Sorry, yesterday I was not able to teach the two sessions yesterday. Supposed to teach the free uh, um, workshops during the summer. Yesterday it was from 9 to 12. It's supposed to be for the Civil Breath AM. Something came up yesterday early in the morning, urgent, and I have to keep myself busy with that. Even the internet was down for 2 hours. I tried for 2 hours to send the email as early as I can, and finally it did work a little bit late. Today is the 5th. This we are here today, but construction yesterday also was missed. So I will try to find two spots to make up these two sessions that I missed yesterday. Sorry for that, but during this uh, uh, time or during this period, a lot of things is happening. So I have to take care of my family and my health and some other issues, some friends, some many issues going around us, and I wish the health for all of you and safety for all of you, everybody in the world, to be safe and healthy, because the number I heard this morning is really a frightening number. Even I was reluctant to come because I have to come to the office to teach the class here from the office, and every time I leave the house there is a risk. Everybody go out, there is a risk. I'm lucky that our office is very close to my house, so driving very short distance, and but I'm taking the risk. I'm taking the risk by coming to this place. Just pray for me and pray for you, and may all of you to be in safe and health, and your families and everybody in the world. So I scanned something and I sent it this morning. Sorry again that I scanned it and sent it, or emailed it. In fact, it is a PDF file. Yesterday also I scanned something, or no, my assistant, somebody came from the office. They came and because my staff, they left the office and they are no longer working from the office. They are working from home. However, anybody can come and help me here. I always look for that. So uh, so we will do our best. We will do our best this crisis and or this era. So somebody scanned yesterday. It could be myself or somebody who is the mini exam number one with some kind of solutions for some problems. We'll solve it together, and the rest will follow up. The mini exam number two, the one I emailed it to you a few minutes ago. Appreciate if you can print it and you can join me, okay? Or I can give you 5 or 10 minutes to print it, or during the break. So today is according to the schedule. I will try to stick with the schedule and make up any session that I missed because of this crisis here. The two sessions I missed yesterday, but today is the fifth, and we are going to do our best here. And also I'm trying to follow the order of the NCEES as far as the topics, which I already included in my three books, the textbook itself, and this is what I'm reference my material or my solutions to, which based on the 12 references, and I will keep adding more problems, okay, and also the other two books, the AMBM and the transportation practice exams and solutions. So I'm trying to do my best, and do your best, and we hope that we can have this crisis over or behind us very soon. So if you go to so mini exam number one was talked about or talking about the AM portion of the transportation, which they call it geometrics. Geometrics, as all of you know, they call it geometrics nowadays. So this is for the AM, which is basically there are three topics under geometrics. This is for the topics related to transportation PM. So horizontal curves, vertical curves, and the traffic volume, flow, speed, and density. If you remember, the density D and is equal the flow rate divided by S. This is a very important equation. This D, we are using this D for density, and V is the flow rate, and they are using S for speed. I know there are some letters that we use it differently, but this is a HCM. I'm talking about the HCM 2016. The Highway Capacity Manual, as you know, is a current reference for the abbreviations that we are using for the LOS calculations. I know the AASHTO, the new AASHTO book, the AASHTO 2016, 2018, sorry, 2018, the 7th edition, they are not using, they are talking about density and the speed and the flow, even they have the graphs, but they are not using letters. They are talking about the concept, and already I talked about that. So this is for the AM, and this was in fact related to or these three topics, and always I look to back to see if for example, the mini exam number one, the one you received it, and I hope that you get a chance to work it out. And if you find anything that you would like to discuss, I will be glad to do that. If we jump to the PM, as you know, the PM, the transportation PM, transportation depth, they have 10 chapters, and I try to follow these chapters as much as I can. But you will find there are some problems from here or there, because I believe the exam, I don't know, they are going to give the exam in the same order as it comes in this sequential order. For example, this is chapter one, which is the biggest chapter, in fact, or the largest number of problems. Chapter one, they call it traffic engineering. This is again per NCEES. and I hope they will not change anything this coming October exam. If the October exam will be held on time, I hope so. I hope the exam will be held on time. I believe it is October 23rd. So the exam is October 23rd, according to the current website of the NCAAS. And I hope this crisis will be way over before that. At least everybody will get a chance to get the full speed of studying and the preparation. And when I start teaching the courses again in July, obviously, as I mentioned before, those of you who attended the class with me last spring, or this spring, in fact, the spring is not over yet, for sure automatically they will be enrolled in the class, and I will start from where we stopped. Okay, I'm not going to start over again from the beginning. I will start where we stopped, and after that, those who are going to join me the first time, they will get the chance to get the whole story or the full story when I start over again after I finish the subject or the course. I will start from the beginning, from chapter 1, and keep going. So this is just to save time and to give you a chance. So if you look to chapter 1, which is traffic engineering, this is a very healthy chapter, and it has topics, and always look to these topics, and they are available in the NCAAS, and I put them in all my books, even this book here, which is, let me get the other book, at least I will not. At the beginning of each chapter, I try to list the topics. At least it will guide me. Okay, what are the topics that I missed, or I need to? For example, chapter 1, which is 27.5% of the 40 questions, because this is 11 questions, as you know. So you'll find that uninterrupted flow, level of service, okay, street segment interrupted flow, intersection capacity, traffic analysis, trip generation and traffic impact studies, accident analysis, non-motorized facilities, pedestrian and bicycles, traffic forecast, and the highway safety HCM, the highway safety analysis. Okay, the highway based on the highway safety manual, the highway safety manual HSM. So the HSM, the highway safety analysis, they are talking about the crash and modification factor, CMF, and we talked about that. So exactly, I try to do my best to come up with some questions that related to these topics. And if I miss any topic, for sure, I will go back and include it in the mini exam number 3 and so on. So I'm trying to do my best, and please do your best, and we will keep working together until this crisis is over. That's it, I think. So before, just one very quick note also, I don't like to take more time. Today also, I do have a seismic class. A seismic class, I will be teaching seismic class from 1 to 5 p.m. The seismic class or the seismic review, this is for California only. It's not for nationwide. For those who are in California or those who are planning to take the California license, they have to pass the seismic and surveying plus the take-home exam, as all of you know. So I will start teaching the seismic again. I just finished it, in fact, 2 weeks ago, and finished the entire course. It was based on a new code, based on the ASCE 7-16, and I updated my books, and we covered the class, and it is loaded right now on our website, sorry, on the server, and it will be available as on demand for those who are going to take the class. However, the second quarter, which will start today, I have 28 hours. It is just to go and solve problems only. Even the 28 hours itself equivalent to some courses available in the market, but this is workshops only. So, and I decided yesterday to make it for free also, just to help everybody. For those who are interested, they are going to get only the workshops. They are not going to get the on-demand, obviously, and no books, obviously. Okay. But if you'd like to join, if you are already studying or you have, here it is. These are the 2 books I'm using for my seismic. Okay, this is the second quarter, and this is based on the new codes. And already I finished about 55 hours on demand, but I have 28 hours. I call it workshops. I will be devoting those 28 hours to solve problems only, and explain any concept on the seismic. If there is a request from any participant to explain a concept about torsional moment, negative torsional shear, name it, or any kind of or any topic that in the seismic um, exam specifications. So if you like to attend or you like to pass this to a friend, I was going to send an email, but also I got distracted by too many things. But this is the ID. Again, if you just write just www.joinwebinar.com and one enrollment for all sessions, onewebinar.com, and enter this ID. This ID only for seismic. Okay, so this is only for seismic. If you use this ID for any other course, it will not allow you. Okay, and you already have this. This is very quick. So the first step, I have about 26 problems. I did my best to select as many as I can, as related to the topic, as topics as many as I can, and you are very welcome to work all these problems and try to do your best. So the traffic analysis or traffic engineering of the NCEES listing of topics, uninterrupted flow, which is one of the volumes of the HCM, the Highway Capacity Manual. They came up with these 4 volumes, 3 volumes. They are available as a hard, and the 4th one, it is on. So this is today is 3. This today is 4, 5, 20, and this is a transportation PM. So forgive me for those who yesterday for the AM and for the construction that I was not able to make it yesterday. So the chapter 1, if you like to call it, or section 1 of the NCEES, the transportation traffic engineering of the transportation PM, sorry, traffic engineering. And here the main focus based on the two references are used in this chapter, which is chapter 1, which is 11 problems, as you know, all the 27.5%, which is almost, okay, not almost, more than 25%, which is more than the quarter of the exam. So this chapter itself, it has a weight of 27.5%, which is more than 25% or more than the quarter of the exam. Okay, so this chapter it does have many topics, and they are relying on 2 important references. The first one I just mentioned, which is HCM, the Highway Capacity Manual 2016, and the second one is the Highway Safety Manual, which is the Highway Safety Manual, okay, Highway Safety HSM, okay, 2010, by the way, this is 2010. And I did my best to extract the information from these 2 references. Hopefully, or I am hoping that I extracted enough information and put them in my books. And in the past, I did that, and the engineers, I believe, were happy, and they said that this was good to help them to pass the exam. And I hope this will be the case this time. So the first thing, that LOS determination and the LOS level of service, we need to make sure that we really know how to determine the LOS for the transportation facilities, and there are many transportation facilities mentioned. The freeway, this is the freeway. This is the first one, freeway, and multi-lane highways, and 2-lane facilities, two-lane highways, and some other facilities like roundabout. Okay, roundabout it became very important, and in fact, this is the first time they include roundabout in the corner side distance. If you remember corner side distance or the intersection side distance, we have cases A, B, C, D, E, F. They added G. In fact, this is G. Okay, they added a new um, corner side distance, and we will have this in the mini exam number 3. As far as the corner side distance, I have in the mini exam number 2, I have stopping set distance, and the mini exam number 3 is going to have the corner set distance because it's important. But for the LOS determination, the level of service, the HCM, the highway capacity manual, they came up with these letters, which all of you are familiar with, which is letter A to letter F. Okay, A being the best and F being the worst LOS. And in the AM section, I cover that, by the way. And again, if you have my book, that's fine. If not, I'm not inventing anything. I'm presenting the material. So if you have any reference, you will be able to find this table. So, for example, in my textbook, on page, this is in the AM, on page 53, if you have the textbook. If not, for sure you have this table somewhere, because this table came from the AASHTO, the 2018, or the HCM 2016. So they came up with letters A through F, A being the free flow, and F is a forced or a breakdown flow, which is the worst one, obviously, and this is the best one. So this table that I needed to be aware of, and I provide a brief description for each level of surface. Okay, what does it mean? This is just a summary they provide, but I took each one of them and I try to elaborate as much as I can in a very concise, because you have very limited time. And somebody may say, okay, are we going to design our facilities for A or B or C or whatever? They came up also with a guideline. And this guideline is given in another table, also in my textbook on page 58. Okay, and this table also came from the references, and I provide the reference that I'm referring to. This is the AASHTO 2018, table 2.3, page 237. I hope that everything, okay. And they came up with this guidelines for selection of design level of service. We will never design a facility for level of service A, because it will be very expensive, very, very expensive. Okay, so they came up with this guideline based on, okay, and this is again the guideline, as you can see, is not mandated. If you'd like to design a facility for a level of service A, this is your choice, but it will be very expensive. But for the sake of the exam and for the sake of practicality, this guideline normally we use it. If it's a freeway, if it is arterial, collector, local, and again, if it is rural, okay, or rural level or rural rolling, rural mountain, and urban and suburban. So we're using this table, okay, as a guideline to select what type of level of service, LOS, that we are designed for in order to have a facility that operational and safety, okay, are acceptable operational and safety required for these facilities to be safe. We need to provide safe facilities, but also at the same time, the public will not suffer successive delay because this entire time is a problem for us to lose any time. So they make a balance between cost versus safety, okay, and operation. So normally we look to safety number 1 and the operation number 2, and they try to tie this to, okay, to the dollar figure. Okay, how much money do I have to build a facility? Yes, you can design a facility for LOS of A, but it will be very, very expensive. You are going to provide too many lanes, and nobody will be using for the time being, but maybe after 20 years or 30 years, you will find that, yes, it has a use. But right now, we are not looking for the golden, okay, key, or the golden, okay, facility. Will look for something that to balance between these two based on the guidelines. Again, is not It's not up to me or up to you to determine what is a safe and what is a good operational facility, but we use all these codes in order to determine what is acceptable and what is not acceptable based on the guidelines given in codes. Okay. So the freeway, in the freeway, as all of you know, freeway, this is a facility that has full access control. Full access control. Full access control. That means that I have a fence and nobody cannot get in and out unless there is an interchange or a grade separation, as we call it. So if this a local street here and the local street or local facility in general, could be a road, it could be a okay. So this local facility, it is over a crossing or under a crossing is not the point. The point is the public here, sorry, the public who is using or the users of this facility, in order to get out, they have to use an interchange. Okay. And if the public would like to join in, they have to come and use an interchange. So in and out through interchanges only, or ramps, or as we call it, a grade separation. So this is the freeway facility. It is full access control. Full access control. So in order to determine the LOS for freeways, LOS, okay, for the freeways, they came up with one equation, and this equation is given in the HCM, and the equation is, nobody will ask you memorize equation. I memorize some, I cannot claim that I memorize all. So they came up with this equation where we can calculate what is known as the free flow speed, FFS. So the FFS is given by the code, the HCM code, the highway capacity manual, is given as, and let me write it, at least you can write it after for me, after right, is a free flow speed, FFS, is equal to the base free flow speed minus FL sub W minus F right lateral clearance minus a constant 3.22 times something they call it TRD, and TRD is raised to power 0.84. Okay, this is the equation that's given in the highway capacity manual. And let me put it here very quick, and I will go back again. This is the equation that for freeway segments, for basic freeway segments. Okay, when we're talking about freeway, by the way, we're talking about basic freeway segment, which is a segment between, okay, interchanges. They define a segment for us that it is between, so freeway segments, let me, because the interchanges, they have their own analysis. And also weaving, they have their own analysis. Merging and diverging, they have their own analysis. So a segment that is outside the weaving section or weaving lane, it is outside the merging and diverging, and so on. So they came up with this equation, and this is equation, as I said, HCM equation chapter 12, 12.2. So I will give you the equation number, and if you have access to the HCM chapter 12, you will find this equation. So one parameter of this equation is this here number, which is a TRD. TRD. And this was a major change from the previous code to this code. In the previous code, they are using something is called ID interchange density. If you find a book that's still using the interchange density, that means that they're still using the old code, which is no longer okay used for the calculations. So the ID, interchange density, ID. The TRD, which is a total ramp density, total ramp density, um, uh, is related to interchange density, by the way. But here we were talking about the number of interchanges irrespective to the number of loops or ramps. And they found that this, in the past, using the interchange density alone is not a good measure or a good indication for the LOS. So this is why they get rid of it. And they came up with this concept, total RAM density, TRD, which is part of this equation. This number here, which is the basic free flow speed, has a definition, okay? And the number we are using is 75.4 mph. So if it's not given in the problem statement, the HCM, they are using 75.4. And I believe some of you emailed me because we solve a problem and they asked me, how did you come from where this 75.4 and the 70.4 from the HCM, the highway capacity manual, this like a default value. So 75.4 is the default value for the this free flow speed, and this is measured, by the way. This is the default for base free flow speed for freeway segments only, please. Freeway segments. If he gave it to you in the problem statement on the exam, other than 75.4, use whatever number he gave you on the exam. But if this number is not given to you, that means that you can use a 75.4, and this is what they used in their volume number 4, which is the HCM. As I said, it has, if you decided to purchase it, which I can show it to you, it's a very thick document, volume 1 and volume 2 and volume 3, and the volume 4 online, and I'm sure that um, uh, uh, you have access to it. If you purchase the volume 1 and 2 and the 3, they give you a code where you can get access to the volume number 4 and do it. Anyhow, the TRD, the total ramp density, this new parameters they introduced, they have a definition for it. They are saying that the TRD is the total number of ramps 3 miles upstreams and the 3 miles plus 3 miles downstreams divided by 6. Okay. And the units for this, it is how many ramps per mile. This is what they are interested in. How many ramps? So the units for this, ramps per mile. So they are saying that the TRD is the number of ramps on and off. Okay. 3 miles upstream plus 3 miles downstream, 3 miles downstream, divided by 6. A definition is given, and we are going to take this definition and respect it and apply it in order to pass the PE exam, even if you disagree with it, but it's still, okay, a definition given to us, and we are going to respect that and take it and use it. And so they are saying the following. They are saying that if you do have, and let me use, sometimes when I draw something, maybe it will make more sense, which I showed to you. I did something and I gave it to those who attended the class. I give you the solution, and I don't know if you get a chance to check them or not. As all of you know, that when we determine the LOS calculations, the LOS, this is per direction, not for the entire facility. So if you do have a facility, this is the direction of the flow. If this is the north arrow, let's assume that for the sake of discussion, north arrow. So this is westbound, and this is eastbound. And we have some interchanges, grade separation. Okay, so and so on. So this is interchange number 1, 2, 3, 4, and so on, or whatever the name of. Okay. What is a segment? The segment is defined, a freeway segment. Okay, let's assume that we have a diamond interchange here. And then the other direction also it's a diamond interchange. Let's assume this here is not a diamond interchange, it's a spread diamond originally, but they added loops. One loop here, okay? And maybe this interchange originally, it was a full clover leaf. And the same story, let's assume that symmetry for the other direction, and so on. And maybe they have the loop here. So the interchange type must be given. So the interchange type must be given in the problem statement. Don't assume it, must be given. So it is a full clover leaf, for example. Could be a full clover leaf like this. Full clover leaf. Where we have 4 loops and 4 ramps. It could be a partial clover leaf. But the partial clover leaf, we could have different configurations. This loop could be here, it could be here, it could be here, it could be here. Okay. It could be both of them are here, and the other one, it doesn't have any loops, still called partial. As long as we don't have 8. Full clover leaf must have 8. 4 in each direction. 8 ramps. We call it the loop, we call it a ramp also. So this is on, this is a loop, on and off. They call it ramps, okay? This here, we have 4. Total. This is 4 ramps. Total. Total. So in order to help, when they came up with this concept and they changed it from interchange density to the total RAM density, TRD, I came up with something which I included in my book. I was planning to email it to you, to scan it and send it to you. I will send it to you. I just generate, I gave the definition, and I can scan it and send it during the break. This is the definition of the total RAM density TRD per HCM 2016. It is the total ramps on and off 3 miles upstream and 3 miles downstream divided by 6. So I said, okay, let me generate this hypothetical, okay, scenario, which is whatever given in the problem, but I assume if you have a diamond interchange, a diamond, that means that we have 4 total, 2 in each direction. But the spacing between them must be stated also in the problem statement. We are measuring the spacing between interchange because there is a minimum spacing, okay, minimum spacing for urban and rural areas, also mentioned in the code. So I said that the number of on and off ramps per direction, they are 2 only, not 4, because we are analyzing per direction. Don't forget this concept, please. Okay. And I said, what about if the spacing is 1 mile, 1.5, 2, and 3? What is the TRD? Okay. What about if we do have a partial clover leaf? This configuration here. Again, the spacing it change. Here, the number of on and off ramps became 3 for this configuration, where you have 1 loop in each quadrant, each diagonal quadrant. Okay, here it is, only 2. These 2 corners or 2 quadrants, if you like to call it. Okay, but if you have a full, like this case here, I call it full, you will find there are 4. And we call it full clover leaf. But partial clover leaf also, as I told you, that they can put the 2 loops, okay, in one side or on one side of the interchange. This is still called partial clover leaf, it's not full. Full, even if they add another one here, will be 3/4, okay, but it's still partial. So the only situation that we call it full, this one here, when you have full 4 rams in each direction. This must be given to you, though you cannot assume it. Okay. For example, the problem that I included as a very simple problem, but as I told you, this table can help you a lot, and it could be a question by itself, as I heard that if you complete this table, and I believe I send you the solution for those who took the class, as far as I know, and if you disagree with any of my solutions, if they feel there is a typo or a mistake or an error, please let me know. For example, I gave you a problem and I say, okay, here it is. It is a 4-lane freeway, 2 lanes per direction. Lane width is 11. Right side lateral clearance is 2 feet. Commuter traffic, regular users. Traffic 5% trucks. The peak hour, this is per direction. Also the volume, how many vehicles per hour. And 1 clover leaf interchange per mile. Here we go. 1 clover leaf interchange per mile. So this must be given. And if it is partial, he has to give you the configuration of the partial. But here it is 1 clover leaf. So by default, I say this is full. Because if it's a partial, he has to tell me how many rams on each side of this partial clover leaf. Level terrain. Facility operates under ideal conditions. No incident, work zone, or weather events. The reason they start to add this to the problem statements, and I believe in July, they are coming with the new, I hope they will come with the new blue book, the transportation book, as all of you know. Let me, I think I have some here. The transportation book, I believe they are coming up with something new next fall, next July, I hope so, according to my communication with them. So, yeah, this transportation book, which I believe all of you have it, but I heard or I got a response from them that they are coming with a new set of books to match, especially transportation, to match the new codes, because there are they did not release this, or they do not updated this, and they already changed the codes twice. So, or 2 codes are changed. Let me put it that way. So yeah, 2 codes are changed: the HCM and the green book. So I believe they are working on one new book, and it might be released in July, as I heard from them. So the reason they are saying that the facility operates um, 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 under ideal conditions, under ideal conditions, they introduced in this code 2 new parameters. And these 2 new parameters, based on research done by a couple of professors, one is called CAF and one is called SAF, which is the capacity adjustment factor and speed adjustment factor. So CAF is a capacity adjustment factor, and S stands for speed adjustment factor. And they came up with two tables for us. Again, they are included in the HCM, chapter 11, not chapter 12. Here it is a CAF, CAF, and at the bottom here it says non-severe weather conditions, and they are saying that we are going to take it 1 for any kind of speed. But if we do have medium rain, heavy rain, light snow, and so on, this Professor Ziegler, I got the original paper, is a professor, okay? As you find, you will see from all this research that is done at universities, okay, they always change codes because students, they are doing their PhDs or masters like myself one day. They do research and they come up with new equations, new parameters, and they correct always continuous improvement. This is life. We always continuous improvement. Okay, so they correct whatever was used in the past. And okay, the second parameter is SAF, which is the speed adjustment factor. And again, uh, whatever the condition is, this must be given to you, the type of weather and the type of, okay, condition. But if they said, if everything is perfect, we take it 1. So the CAF and the SAF by default, okay, the default values are 1 or is 1 because 1 for each. Okay, so 1 here and 1 here. If he mentioned this statement to you in the problem statement, here it is. If he said that facility operates under, okay, no incident, work zone and weather. I looked to the weather only because they found that incident, it happening on the freeway, or work zone, if I have a facility here and they are doing some repair here somewhere, so the work zone is going to be a parameter of the adjustment factors. So we need to be aware of that. So the best book I found that describing this very well is a traffic engineering book. Maybe some of you use it, by Dr. Roger and other professors. This is the 5th edition, which is the latest one. They come up with some kind of a table here, and this table also is talking about these parameters, how these parameters are affecting the SAF and the CAF. Okay, and I would be glad to include, I believe I have it typed somewhere, and I would be glad to send it to you in order to tell you, okay, how the, I doubt that they will ask you for the sake of the exam, but nobody knows, maybe a simple question here or there, it could be, okay. So they studied this in depth and they came up with these tables in order to help us to pick up the adjustment factor for the CAF and the SAF. But as I said, that if there is no mentioning in the problem statement about any condition, so in this case, the CAF and the SAF in this case is going to be 1 in each condition, in each case. And I hope this is the case for the sake of the exam. Let us go back again. The peak hour factor, okay, is very important. The PHF, as all of you know, the peak hour factor, and have some problems, you will see it later on, which is the sum of the 15-minute volume divided by 4 times the V15 max. Okay, this is a peak hour factor. It should be very clear to you also as far as calculation. Okay, and we'll go over this at one point of time. But let's focus on one thing at a time, which is the TRD. So the TRD in this case, uh, um, uh, um, the TRD in a given situation, 1 clover leaf per mile. So I took a picture, one of the pictures that I drew it, but is not 1 mile. It is 2 miles. Okay. The picture I pick 2 miles, but I can adjust this to make it okay. I will answer you, my friend. To answer, and this is again per HCM. So if this is 1 mile, and this is 1 mile, and this is 1 mile, you may say that there is no need to calculate because it's very obvious, which is very obvious, yes. But the situation could be difficult, okay? And we can go over this in just a minute. So if you look to this, you will find that if the 1 mile is the spacing between the interchanges as given in the problem statement, and this is a full clover leaf. So in this case, I can say the following. I can say, okay, where is my segment? What is a freeway segment? A freeway segment, it is an area of the, or a length of the freeway, like this one here, freeway segment, that outside the influence for the ramps, because the ramps, by the way, the on and off ramp, they have some influence length, or they call it sometimes influence area, that, so it is away from the influence of these ramps, on and off ramps, and they call this is a segment. So they found that the LOS within the freeway segment in whatever direction is, this could be in this direction here of the analysis. If this is a north arrow as indicated here, so it could be the west bound or the east bound. As we indicated that. So in this case, since the 1 mile is given, so if this is my segment here, okay, I will come to the center of the segment and say, here it is. How far from here to here? This is half a mile. And this is half a mile. Because he told me the spacing between them is 1 mile, given in the problem statement. Okay. So I need 3 miles upstream and 3 miles downstream. If this is the direction of the analysis and they use upstream and downstream like the water, okay, the water flows from upstream to downstream. So this is upstream of the flow, and this is the downstream. In hydraulics, as you know, or the flow lines or contour lines, they decided to call what is upstream and what is downstream. So if they are considering the westbound direction, this is upstream and this downstream. If you are considering the eastbound, this upstream and this downstream. So it depends on the direction. So in this case, it is, I have, okay, but I have another 1 mile here and another 1 mile here. Here it is, sorry, it is written already 1 mile. So this is 2.5 miles. Okay, so 1/2, 1 and 1. So 2.5 miles up to the center here. If I move another half a mile, okay, as you know, the nearest one or the next interchange is here. But I stop it. So half, 1, 1.5. So this will give me a total of 3 miles. And this is what they meant by 3 miles. You see, 3 miles. I will do the same thing with the other direction. So if you count the number of on and off ramps within the 3 miles upstream, you will find that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they are 12, which is 3 times 4. And this 3 times 4 divided by 6 will give you 4 ramps per mile. And these are the units. How many ramps per mile for the TRD? The TRD. Okay. And you might say, I don't need to do this. This is very obvious from the definition. 1 clover leaf interchange per mile. I know a clover leaf is a full clover leaf because he didn't tell me a partial. So here it is. If this is the direction of the analysis, whatever direction is, so for a full clover leaf, I have the following. I have on ramp, I have an off ramp, I have a loop on, and I have off. This for this direction, if you consider this direction of the analysis. If you consider the other direction, it will be the same story. Here it is. Oops, sorry. Which direction? This arrow this way. Sorry. So this is the on ramp, and this is the off ramp. Okay, and this is the on ramp, and this is the off ramp. So it doesn't matter which, as long as this is a full clover leaf as indicated here, full clover leaf. I have 1, 2, 3, 4. So I have 4 ramps per each interchange, and the interchange spacing is 1 mile. That means that 4 ramps per mile. It is very obvious, 4 ramps per mile. From the problem statement, there is no need to do all this, but in case if they gave you something other than the full clover leaf per mile or a clover leaf per mile, so in this case, this chart, it might help, and you can try it for a diamond interchange, okay, for different spacing. For example, if we take the 2 miles for this here, which I said that I will scan it and send it to you during the break. So if we take just a diamond interchange, let's take 2 miles. So which is drawing shown here. So here it is. So I will say that I know my segment is here, and we normally assume that the segment is, so this is 1 mile from the center of the segment to the center of the interchange. The 3 miles is up to here. So 3 miles. This is my 3 miles. 1 and 2. So I count how many ramps in these 3 miles. I have 1, 2, 3, and that's it. So 3 ramps, 1, 2, 3. And the same story, if you go to the other side, also you'll find here. The 3 miles are here. How many ramps? So let me count them. 1, 2, let me number them. 3. And the same story from here, from the center, I will go 1 and 2 and 3. So 3 ramps on and off, upstream, and 3. So it is 3 plus 3 divided by 6. So this will give you TRD of 1.0 for this scenario here, and so on. And I will be glad to send you also my solution, and you can look at it. So this is something that I needed to be aware of, because the other parameters that mentioned in the equation, which we'll go over it after the after I answer the question. I believe one of you is asking a question. The basic free flow speed, already I mentioned it, and the L sub W and F right lateral clearance, they found that the lane width automatically will reduce or will deteriorate the LOS, and this is why they are saying that the LOS calculations for the freeway segment must include the lane width. If the lane width is less than 12 feet, we have to have a reduction, this negative here. And also if the right lateral clearance also, and the right lateral clearance, they limited the clearance to the right. For the multi-lane highways, we consider the total lateral clearance, which is right and left. Because for a freeway, so if this is a cross section, let me just draw a cross section here, and whatever the number of lanes, let's assume it's divided highway. So this is the inside shoulder, and this is the lanes, and here are the lanes, and the outside shoulder is whatever the width is, and the thickness of the pavement should make it similar. So this is the inside shoulder, and this is the cross slope, and here, so these are the shoulders. Let me make it a little bit bigger. Okay. And this is normally cross slope 2%, and this is also 5% this way, and this is, okay, 5% this way. Okay. Unless if you are in a super, so the right lateral clearance, this is obviously the other side is symmetry. So this is, I will call it a freeway segment. So you are driving perpendicular to the paper, so this is the right and this is left. Left, okay. So they found that the right lateral clearance is measured from the ETW. This is called the ETW, edge of traveled way. And this is here is edge of shoulder, ES. Or some book, they call it edge of pavement, EP. They found that if you do have a tree or a fixed object, any fixed object, it could be a power pole or light pole or a tree or whatever you like to call it, any object. This could be a light here, could be a light, it could be a tree, any kind of object to the right of the driver. If this distance is less than what they stipulated here in the code, there is a reduction for that. There is a reduction for that. And this is the right lateral, and specifically right lateral clearance. Okay. So the right lateral clearance, they are saying that they came up with a table, and this table is given also in the HCM 2016. Okay. If the right lateral clearance and they are saying, or the statement here, it is the right lateral clearance is measured from the right edge of the travel lane to the nearest lateral obstruction. This is the definition. So I needed to be aware of that. Measured from the ETW of the right edge of the travel way. Here it is, measured from ETW, as I mentioned. Okay, so it's not measured from the edge of shoulder. So if the distance is greater than or equal 6 feet, this is the right lateral clearance. And the number of lanes, they are 2, all the way until 5. All of them, we take this 0, no reduction, no penalty for that. But as the distance start to get smaller, the right lateral clearance start to increase. So the number of lanes start to decrease. You will find that the reduction, and this is mile per hour, by the way, mph. Here it is, mile per hour. This is like a penalty. If Mr. Mansour or a designer, he designed a facility and there is a light pole, okay, is closer to the ETW, they found that the driver, okay, will automatically will slow down, okay, because he's concerned about his safety, okay, because he's concerned if he got off the road from the ETW, he might hit this power pole. So they found that this, and this is based on actual measurements, by the way. They found that the average running speed, what is a posted speed? Posted speed, because the facility is designed for a certain speed, which is 85th percentile, as all of you know. and the speed studies are important. Okay, so they found that the drivers, okay, automatically will slow down because of the closeness or the lateral clearance. The left clearance is not okay, is not considered here because this is a freeway. Okay, all these things. So the equation when we are saying that the free flow speed FFS is equal base free flow speed, which is I told you it is by default is 75.4 minus F L sub W lane width minus F right lateral clearance minus the constant 3.22. Okay, this famous number, and they came up with the TRD, and this is raised to 0.84. Famous equation, uh, and I hope that. So the lane width, also the lane width, they have a table, this famous table, all of you, I'm sure that you used it, and the table is a little bit confusing, a little bit. Okay, but this is their intention. This is FLW, which normally, okay, I put something here, okay, LW on the side here, but I prefer to FLW, lane width. I will write like this with a marker as indicated when I was teaching the class. So, so if the lane width is less, greater than or equal 12, it is 0, sorry, 0, no reduction, okay, okay. As you can see here, it says greater than or equal 11 to 12. So if you have 12, shall you use this or this? No, you use, okay, this. This here, this 12 here, what they meant, it is 11.999. It's not 12. The moment I hit 12, I will take it 0. Anything less than 12, okay, and the greater than or equal 11, the same story here, between 10 and the 11. This is what they meant here. This is 10.99. It will not really happen, but just I'm telling you what they meant. Okay, so there is a reduction as the lane width start to decrease from the standard lane width, which is 12 feet. Anything 12 or greater, there is no reduction. So we have to accommodate that. So please look to this equation and look to the TRD, and I will do my best to explain as much as I can and clarify as much as I can. Let me grab something very quick. Sorry, my friend, you waited too long. Alex is telling me, I'm sorry, my friend. Alex, at about 10 o'clock, sorry, I thought this is a question, Alex. And he said there is no sound. From my end here, I know the internet is causing too much stuff nowadays. As you know, everybody is using the internet and Zoom and all these fancy connecting and movies and download movies. And so it from my end here, my friend, the sound indicating that's working. So if your end, okay, sound is great. So I got also indication from other engineers that are telling me the sound is great. So what I recommend for this is a general statement that if you have a problem with the internet from your end, for whatever reason, as I told you yesterday, I was waiting here 2 hours yesterday for the internet and to send the email that I will not be able to teach yesterday. And I turned the router in and off and connect this. I did every possible trick they told me about to do it. And unfortunately, it was not, it was down for some reason. And it came out after 2 hours. So generally speaking, if you if you have a problem, please, okay, it's now fine. That's good, my friend. Okay, I'm glad to hear that. Okay, so let's take a short break and try to get some fresh air, air free from any coronavirus, please, because the CDC yesterday, heard the news. The CDC they announced that it is airborne. Okay, CDC. Even our president in his conference yesterday, he said that yes, wear it, but I'm not going to wear it. Why? Just if I wear him, probably I will put one during the conference to give a good example that we should follow the mask. I believe in the mask. In fact, my daughter was telling me 3 weeks ago. I told her I feel comfort when I wear the mask. When every time I go out, like for example from my home to here, which is a very short drive, as I said, I still putting the mask and wearing the gloves and spray everything, because it's a virus. So why is not airborne? What's the difference between this virus and the influenza virus in the past? I'm not a doctor, but I told my daughter, no, it does not. I will be feeling more comfortable. Until yesterday, they said, no, you have to wear a mask. So please do your best and let's try to. So if you get fresh air without any coronavirus, please. Okay. And do your best. Try to be safe. Okay. Let's meet after 10 minutes from now. Thank you very much. Okay, welcome back, everybody. This is a table I was referring to in this textbook, from this textbook, Traffic Engineering, the fifth edition, which is a current one. When they start to develop CAF and SAF, so they consider the parameters that will affect these two adjustment factors. For example, whether, let me write it very quick for you, at least you have access to it. So the CAF and SAF, okay, the parameters that they considered and develop these factors for us, and this is again based on research by these two professors. So the condition, make my table a little, I'm trying to do it by hand. Okay, so the condition that will affect these two parameters, whether, yes, both of them, whether, yes, and yes. And the second one, incident, any kind of events like spillway or accident or something like that. So this is yes, and this is no. Okay, and the driver population, which we in the past we used to have a driver population factor, which is 1 by default, and work zone they introduced the first time. So the work zone, they are saying that if we do have some work to be done, work zone, so yes and yes. So you see, the only one that was not considered for the safety adjustment factor is the incident, like, okay, like accident or um, uh, uh, um, spillway or anything like that. And this is okay, as I told you, and they came up with different tables. I believe that uh, uh, um, I don't know, they might ask you about that or not. For example, SAF and CAF for non-standard driver populations. If the driver is familiar with the facility, we take it 1 and 1. Okay, but start to come up with all the way to until they come up with all unfamiliar drivers 0.852 and 0.63 0.863. I'll be glad to send this table also just in case. And okay. Another thing that so this is the CAF and the SAF um, adjustment factors. By the way, I scanned the sheet and sent it to you. So if you check your email, please, you will find that this table, the one, even I scanned the one I was using it here in the class. So at least you can refer to it, and you are very welcome to do it and let me know if there is any. Uh, uh, the uh, um, let me see here. I lost the view. Let me view questions. Yes, here we go. To see what's the question here. Uh, I think the TRD is 2 for the exam number 2. Okay, I will look to that. Alex is asking a question. Um, 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 let me answer two questions at the same time. Alex is first of all is asking is recommending to buy this book or not. Um, um, the fifth edition. Um, um, the fifth edition will have something, okay, not included, which is the I didn't check if they came up with the sixth edition or not. They came up with the fifth edition after they changed the HCM to 2016, but they did not update it to the Green Book. This is not updated to the Green Book. When I mentioned this was published, let me take it back. Let me take it back. It is published. It's 2019. Let me double check to see if they consider this is they refer only to the highway safety manual, only the HCM. Let me see if the Green Book uh, um, no, no. Yeah, yeah. If you look to the introduction here, my friend, they are saying here that this is the fifth edition of the textbook and includes the latest standard criteria. MU to CD 2009, I have no problem with that, as updated. So, the policy of geometric and design of highways, okay, this is 2011, and the Highway Capacity Manual 2016. This is the current one, Highway Safety Manual. So with the supplement 2000, okay. So they have a problem here, or I have a problem for policy on geometric design of highways and the street 2011. They are using the Green Book, the old one. So the Green Book, the Green Book, which is this one here, they are using this one here. This is a 2018, as you know. It must be the seventh edition where I updated my book. So let me search to see if they came up with the sixth edition or not. Maybe they have a sixth edition. So hold it until I will search. The geometric design. Geometric design is not geometric design. Um, we need the seventh edition, which is 2018, as all of you know, which is they did changes. I hope that the fifth edition, the sixth edition came out from this book. I have the fifth edition, which is Traffic and Highway Engineering by Garber and Hoyle. Garber and Hoyle more familiar or more popular than the other book by Dr. Roger. Okay. For some reason, and I noticed that the transportation, the the transportation, the blue book, um, the blue book, okay, of the NCEES, for some reason, unless they refer to this, Dr. Roger also, I noticed that most of them, they are in reference to the, which book is that? Transportation. Yeah, most reference, I think the reference to the to the to Dr. Uh, no, they refer to it also. Here it is. They refer to it. Problem 5.5. They refer to problem. Okay, uh, okay. So they are referring to it as a third edition, but right now the fifth edition already out, because as I told you, Garber and Hoyle they are referring to also the Garber and Hoyle. Okay, which is so. Let me make my homework and see, my friend, if they come up with a new edition. I prefer Garber and Hoyle. Garber and Hoyle, yes, more expensive, and they call it the Bible for traffic and highway engineering. This is only a traffic engineering, so probably this is much simpler. Okay, Roger's book, okay, is much simpler than the other one. The other one is the most comprehensive one, Garber and Hoyle, the Bible. Okay, I have it since it was the first edition. Right now, it's supposed to have sixth edition, but I don't know if it's released or not. I have the fifth edition, but still based on the old book. So hold on it until we still have time. I will search on that and come up with a book, or if somebody came up with a book that it does include the geometric design of highways and the street, the 7th edition, 2018. Just to answer your question, my friend. Um, 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 uh, the problem, and this is a solution here. The solution is 4 ramps per mile. So I wonder, one of you is telling me that the answer is 2 miles per mile. No, it is 4. And the answer is correct if it's yes. So this is for the one I send it to you. Okay. So look at it and let me know if you still disagree with my solution, and try to finish the other one. The other thing that I need to pay your attention to, they came up with something is called um, uh, uh, something they call it a breakpoint. Um, a breakpoint in the previous one, they used to have equations uh, for different speeds, but the new code they came up with a breakpoint, and the breakpoint they give us equation. In fact, they give us 2 equations. One equation where it say that this equal this without any calculation, and the other equation if you are on the curve. So what they did, and let me explain this, hopefully this will make more sense to you, which is this figure here, which is taken from the HCM, and this is available in the HCM. So this is what I meant by 2 equations, this equation and this equation here. What they are saying is, when they develop this concept here, they are saying that if the free flow speed along the straight line portion or the linear portion, straight line portion, so in this case, the S, because the whole story is how to calculate D, the density of the facility. And the density, as we, or as I mentioned at the beginning, D is the flow rate divided by S, speed. And this is the flow rate. Okay. Speed, we take it from the flow rate speed curve, which is the one I was putting on the screen, but let me do it here. At least you can, when I scan my notes, this is the flow rate. And the flow rate, by the way, is defined as passenger car per hour per lane, LN. So they are saying that if we have one lane, okay, this LN. If we have one lane, normally we assume that the lane is 12 feet, okay, if it's standard lane. And we have a bunch of cars. And these cars, they decide to go with the PC, passenger car, where we convert all the heavy vehicle into the passenger cars. And these passenger cars are occupying this lane, and within 1 hour, how many cars are occupying this lane per hour per lane? Okay, so this is what the flow rate. Okay, so the flow rate is the number of passenger cars that will occupying, okay, or going through a one lane, okay, in 1 hour. Okay, this is different from density, because density, it is, this is, if you look to the units here, passenger car per hour per lane, LN. Let me use H also without HR. The speed is mile per hour. Mile per hour. Okay. So if you look to this, you'll find that the hour will cancel with hour. And what is left for the density is the passenger car, okay, per mile per lane, or per lane per mile. This is a D. Uh, okay, so the uh, they are using MI for mile. I was checking to see. I need to be careful. Passenger car per mile per lane. Okay. So what is this is MI? Okay. So what is the density? The density basically they are telling us this is the flow rate. This is V, which is the flow rate. Units are very important. This is D, the density. They are saying if you have one lane and this one lane has a length of 1 mile, and you stack bunch of passenger cars after we convert all the trucks and the RVs and all the heavy vehicles. So all these are BCs. How many of them occupying one lane over a length of 1 mile? This is what's called D, density. And this is the flow rate. And here is the speed. And this is mile per hour, MI per hour, mile per hour. So they came up with this graph and they are saying that, look, if you have whatever flow speed is, it will stay constant up to a certain limit in relation to the flow rate. Okay. When the flow rate is 0, we have what is known as FFS, free flow speed. And the free flow speed is defined as the speed that the driver can move freely without the impact of any other vehicles sharing the facility or sharing the lane. So up to a certain point. After that, the relationship between speed and the flow rate is no longer constant. Will start to come to be a curve. Okay. Up to we hit a certain point. And this certain point is the maximum density. This is the maximum D, which is 45 passenger car per mile per lane. And they say stop. And this is going to be the maximum capacity that can be carried at this stage. So, and this is what, let me show, this is my Egyptian drawing here, forgive me for that. Let's show you that the one that was scanned from the original document from the highway capacity manual. Okay, so this is, they call this point here is a break point. Here it is, a break point. Right now, the curve is start to be, the relationship start to be non-linear, and here it is. Up to the maximum density, which is 45. Because this is the level of surface F, by the way. There is a table, you are going to see it. So if you are along the linear portion, you are going to use this, where the speed is equal the free flow speed adjusted. And we adjust the free flow speed after we calculated based on the equation that I was telling you about this here. This is unadjusted free flow speed. After that, we are going to have another equation, which is how to get the free flow speed adjusted. Okay, we multiply this is a calculated free flow speed. Let me put it that way. This is a calculation or calculated free flow speed. This is calculated. We have to be careful about the terms, because one word on the exam, he can tell you, okay, what's the calculated free flow speed or just the free flow speed. If he say the adjusted, he means something else. Okay, and this is what I included in mini exam number 2, by the way. Okay, so this is the calculated free flow speed. Okay, so the equation for the curve is given here. It is. So the S is equal to the adjusted free flow speed, the FFS adjusted, minus this equation here, minus this. And I have some problems related to this asking you, because intentionally I put my numbers to force the problem to go into the curve. Okay. And here the flow rate, V sub B, by the way, we call it the flow rate. The flow rate less than or equal the breakpoint. So if the flow rate equals to or less than the breakpoint, I am here. I'm along the linear portion. And in this case, there is nothing to do except just calculate the FF adjusted, and this is the speed that will be used to calculate the density. The density, let me write it. I don't know why I didn't write it. Here it is, the green one. The density, which is the flow rate divided by S. And this, our ultimate goal is to get the density, and from the density you can get the LOS. So if you are given some data that will force the problem to go into the curve, so in this case, the V sub B, let me zoom in here. This curve is very important. V sub B, the flow rate, V sub B is less than or equal C is for the capacity, and BB, which is the breakpoint. So in this case, we have to use this equation. And the equation is a little bit lengthy, but I have some problems. This is raised, okay, to the power A, by the way. Okay, so make sense? So I know you will get familiar with all these things. Already I explained all these things, and all these things are given. Okay, so I hope that, but be careful, because the B sub B here is sometimes, or they may ask, I don't know what they are going to ask. Okay, this is BB. Okay, this point here. BB. So this is the break point, which is this one here. Okay. And so if you are less than or at the break point, so the S, as I told you, the S is equal the free flow speed adjusted. So here S is equal FFS adjusted. Okay. If you are here along this curve, so use equation. Okay, and we need to be aware of that. The if adjusted, by the way, is given also by the code, by the based on a table they provided to us, and this table already I covered it. Okay, the here it is. This table is the table that is provided to us, where you have the FF adjusted, the adjusted free flow speed is equal the calculated free flow speed. So the FFS adjusted, if adjustment is needed, and I mentioned this in the, you will find some problems in mini exam number 2 related to this, is equal the calculated FFS, calculated from where? Do you remember the famous equation that I wrote it 2 times so far? Is equal the base free flow speed minus FL sub W lane width minus F right lateral clearance minus 3.22 TRD raised to 0.84. This is a calculated free flow speed. You need to multiply the calculated free flow speed by another factor, which is SAF, which is this equation given here in the table of the, this is exhibit 12-6 of the HCM 2016 on page 12, if you have the original document. So this is the equation that we used for adjusting the free flow speed. Adjust the free flow speed. Here it is. Okay, so I needed to be aware of that because sometimes they can ask. The second equation that they introduced in relation to the LOS calculations, and this is the equation that is related to multi-lane highways. Multi-lane highways. Multi-lane highways is not like the freeways. This is partial access control. Partial access control. The freeway, it was full. Do you remember the word full? Here, the facility, yes, it have a fence somewhere, okay, along the facility, but at a certain location, they have intersection at grade, a county road or a street, and the fence will start after that. Here, this is a local or county road. This we call it intersection at grade, no grade separation, intersection at grade. At grade means at the same level. So the users of this facility here, they can leave or they can enter the facility, join the traffic through the intersection. So there is nothing to prevent them. This is called multi-lane high. This one word, by the way, multi-lane highways. Sometimes we use the word expressway, but the official expressway equivalent to the multi-lane highways, multi-lane highways. Okay, so it is partial. The word partial is very important. So they said, oh, in this case, we need to introduce another factor because of this. Because when the traffic start to leave or start to merge, it's going to affect the LOS here. I'm driving behind and this gentleman or this driver start to slow down. I have to slow down, will slow, and so on. If I join the traffic here, I will make impact on the LOS. So they came up with another equation. And the other equation, it does have more parameters than the equation that we used for the, and this is the second equation that for the multi-lane highways, which is this equation here. So be careful during the exam or on the exam what they are talking about, which facility they are talking about, because one word can make really our direction. So the free flow speed is equal the base free flow speed minus F sub W, F LW. It is the same as in the other one. Here it is, FLW, FLW. As for the freeway segments, the one that has a full access control. Here, it was right lateral clearance. Do you remember the tree or the power pole? Here they are telling no, it's total lateral clearance. It's not only the right, only here. They consider the total. And the total is the sum of the right and left. Here it is, which is the total lateral clearance. Now, there are two additional parameters added here. This here is FM. This for the median type. If the facility has a median or not. And we'll see what about if we have a concrete barrier in between the two directions. There is no median, but we do have a barrier, concrete barrier. So the FM is this something new for multi-lane highways. And the access point, F sub A, stands for adjustment for access point density. How many access points, how many local roads or how many county roads connected to this facility? How close are to each other? Okay, it's called access point density. Access point density. And this is normally it is how many access points, okay, per mile. Okay, if you look to the access point, which is the FA, how many access points per mile? If they are zero, there is no reduction. Obviously, there is no penalty for that. But when the access points start to increase, as you can see from this table, the penalty start to be, because all of these are negative signs. You see the equation. Let me write the equation, which is the second equation for the free flow speed for the multi-lane highways. The FFS, okay, the free flow speed. Again, why we are calculating the free flow speed? In order to get the density. So the free flow speed for the multi-lane highways, multi-lane, is equal to the base free flow speed minus FLW minus F total lateral clearance TLC, which is the sum of the right and the left, minus F sub M minus F sub A. Access points. Access points, this is a number of access points per mile. You have to calculate them if it's not given to you to get the reduction. And get the reduction F sub A from the table that I was talking about. So the effect, so for example, I believe, if I'm not mistaken, I have a problem. I don't know if you get a chance to print it or not. If not, please do your best. Yeah, here it is. Problem number 15. 15. He told you that access openings spacing is 300 feet. Okay, so he said that I have a facility and I have access points. Whatever the direction, okay, So not necessarily he will make your life easy by giving you so right now, this is the direction of the traffic, 4-lane divided highway, okay? Assume this is the median in the middle divided here somewhere. I will make this is a median here. But he did not tell you, okay, he's telling you from here to here is a 300 feet. So in this case, in order to use the table I was referring you to get the reduction due to the access point, you have to calculate, you have to convert the distance between two consecutive access points to how many access points per mile, which is basically 5280 divided by the spacing, which is the 300. So this 300 is the spacing. That means that you need to get the number of access points, per mile. You are going to take the mile, which is 5280 divided by 300 feet per space. This will give you a number. So not given directly. Be careful about that, by the way. All these things are a little bit tricky, and we need to pay attention to that, okay? So this is something that I needed to be aware of. And so the FA median, also the median type and the median, if the median exists, TLC, total lateral clearance, FW lane width, base free flow speed, okay? So all these things are parameters that it should be considered. They are using only one table for both, by the way. After you calculate all the stuff and you reach the point of the density. So our ultimate goal here for the LOS calculations, LOS for the freeway segments, or for the multi-lane highways, after getting D, which is the flow rate divided by S, both of them, you are going to use this D to enter one table, and they put also in a form of, okay, one table, which is this table here is given. Let me make sure that I'm talking. Okay, this is a table that they came up with in order. So this is a D density, which is a flow rate divided by S, which is a passenger car per mile per lane. So this is for basically freeway segment and multi-lane highway. So we are using one table to calculate if the level of surface is A all the way up to F, which is, I told you, the 45 is the criteria. The demand exceeds capacity or density, okay? So in this case, we have LOS of F. But this is one table. It used to be in the past two tables. They joined them on one table, okay? So after getting the density D, you are going to come and calculate, after calculate the density, you come and compare your density value with this table in order to come up with what is the LOS. So you are looking for the density and you go backward this way and so on. This is something that I need you to be aware of. Um, um, uh, uh, this is something very, very important. Another thing that before I leave the freeway segments and multi-lane highways, and I included, I did not include a problem, probably because is the number of lanes. It came more than once in the past that determination, the number of lanes freeway segments, and multi-lane highways. Okay. He will tell you what are the number of lanes, and I will be glad to include a problem. I did not, if I'm not mistaken, because forgive me, I have too many things in my head. Sometimes I forgot what did I eat this morning, what did I eat yesterday. So sometimes I say I did that, and it turned out to be not true, not because I intentionally or try to lie or lie, not intentionally. Okay, but because too many things can be really mixed with other stuff. So the number of lanes, let me write it down here at least next time. So the because this is a very I heard that this was um, um, a frequently asked question, let me put it that way, or most common question, or the question that has been repeated, or question that has been asked, whatever you would like to call it. So which is the that instead of giving you the number of lanes, a number of lanes, by the way, per direction, by the way, per direction, because there is one equation, I will show it to you, and the n is the number of lanes per direction, which they are using n as in Nancy. Let me make sure that they are using uppercase or lowercase, but to the best of my knowledge, was uppercase. Okay. Yes, it's uppercase. Yes. Yeah. So the equation here, this is the equation I'm referring to in the number of lanes in analysis direction, which is the direction of the analysis, and not the total number of lanes. Okay. So the n is the number of lanes per direction in the direction of the analysis, as I said. They will give you all the information, including the number of lanes, and he will ask you for the LOS. Okay, this is one type of problems that you might see. Okay, the other type of problems, he will tell you, I have LOS C. I need to achieve LOS for this facility to be C, the backward, the number of lanes. Also, obviously, per direction, which is N in this case. This is unknown. So this is backward. So this is given, and we are looking for the number of lanes. Here, this is given, the number of lanes plus all other parameters. I mean all other parameters, but here I'm focusing on the N, which is the unknown. Okay, so the number of lanes here is given plus all other parameters to get what is LOS. Here, the LOS is given with all other parameters and asking what are the number of lanes. Okay, and be careful, the answers A, B, C, D. He's asking for the total or for the number of lanes per direction, because this could be because this we determine the number of lanes per direction, and after that we multiply by 2. Okay, so so the question here, that the answers given here, these are the total number of lanes per facility, for the facility, or the number of lanes per direction. Because the equation will give you per direction, by the way. So if he asking for what are the total number of lanes for the entire facility, I'll multiply this number in by 2. And most likely he will give you the answer, both answers, by the way. He will give you the number of lanes per direction and the total number of lanes, and he can modify the question such that if we miss one word or we didn't pay attention to this keyword. So please look to this, and I will be glad to. So this is an item that probably missing, and I will keep adding. And you are very welcome to email me if there is a specific item. Just tell me, very specific, without really too much um, uh, um, uh, explanation. Just give me, okay, give me the topic, or topic or topics and the subtopic in a very short email, info@bestpe.com, and I will do my best. Include a problem related to, and that's it. Okay. Or discuss info@bestpe.com, as all of you know. Everybody wants to pass his PE, so info@bestpe.com. So this is the email that all of you know it. And some of you already sent questions, I believe. My friend from New York, I hope that everything looks okay in New York, because New York this morning they have a very bad news over there about the number of deaths. Okay, has been increased sharply. Even my daughter and her kids and her husband over there in New York also. But what can we do? They cannot move, and so this okay. The um, um, the following thing, which is the last thing related to this. Oh my God, our friend is giving me very bad news. Okay, thank you very much, my friend. Try to going crazy. I know. 12,000. Oh my God, the numbers are like crazy. Just take care of yourself, my friend. Take care of yourself. I know the situation is so bad. The only thing that we have, or we in our hands, is to take all. Don't take it as a joke, my friend. My friend, please. Okay. Don't take it seriously. And this is what happened. I'm not a politician, or I'm not defending any party, Republican or Democrat, but I believe we have to take it extremely serious. Extremely serious. I believe uh, the beginning at the beginning from January was supposed to take it seriously, but whatever happened. But from now on, let us take all the necessary. Don't take risk. It doesn't matter. If somebody call you, okay, I have the PE exam here in the front of my house. Come to my house. I will give you the PE exam in writing. Tell him, no, I'm not going to come, even to this degree. He will tell, I do have all the questions for you, the PE exam. I told, no, don't go. The joke, probably heard it. Probably there is tons of jokes nowadays, and social media and texting, and oh my God, everybody is sitting home and doing something. Okay, like the kid is telling his dad, um, Daddy, why I need to do the homework if the coronavirus will kill everybody and we will die? Why I need to do the homework? So his dad told him, so when you meet your Lord, you will not be okay a dumb, you will be smart. So a friend of mine, he was calling me, and this was last, I think, couple weeks ago, and he was talking to me over the phone. He told me that, Dr. Mansour, why I need to bus for the PE, study for the PE, if everybody will die, and they are estimating 100 to 200,000, sometimes a million in the United States will die. Maybe I will be among them. Why I need to study? I'm not going to study until I told him study, but don't quit studying. He told me, but what will happen? I told him, at least when you meet your Lord, you meet your Lord with PE. Okay, we don't how you are going to meet your Lord without a PE. So let us do our best. Please do every safety measure you can do uh, to protect yourself and your family, your neighbor, the entire nation. If you come up with some medication or some kind of way to protect the people, do it. Do it. Help your neighbor, help your friends, help your relatives, help every human being exists on earth, please. Okay. And I hope that all of us will get out of this as soon as possible, and will resume again eating and drinking, and go to the movie again, and sit together and study the PE again, and the last thing which I included in the mini exam is the two-lane conventional highway, two-lane highways. Two-lane highways, as all of you know, it has no access control at all. So we are uh, from full access to partial now, no access at all, no access control. No access control at all. Okay, anybody can get in and out, which is, they call it conventional highway or the county road, but the two-lane highways, conventional highways. This is the other name, conventional highways. So if you look to the facility, you will find that the facility is like this. It is have a center line and one lane in each direction. We might have a shoulder, and sometimes we have a passing lane. So basically one lane in each direction, and the shoulder. Why I added this line here? Forgive me. Okay. So one lane in each direction. Here we are getting a little bit uh, into series of equations and tables and the charts. Unbelievable. They came up with this in chapter 15 of the Highway Capacity Manual. Here, there is no fence at all. So anybody can get in and out. Anybody can jump and with a car, as long as safe, you go and join, and you can leave the facility. Same story, you can join here, you can leave. So no access control at all. So for two-lane highways, the process became a little bit difficult because no control. Okay, like the virus corona, you have no control over a lot of things. So it became so difficult to control this virus. When you have no control over anything, the analysis or the remedy or the solution or the vaccine or the treatment, it takes a little bit. It's not impossible, but it's difficult because you know exactly how the people will behave when you have a access control, or even partial access control. You know exactly how the people will behave, or how the drivers or how the users will behave. But when you have no control at all, so anybody can do whatever he wants to do. Okay, as long as obviously safe. This is a criteria here. So they came up with three types of facilities. They call it a class 1 and a class 2 and a class 3. And in the problem statement, he has to tell you what type of facility he's talking about. Because for a class 1, for two-lane highways, class 1, we need two measures. One is called average travel speed, ATS, and percent time spent following, BTSF. For class 1, we have two measures. You have to calculate or determine the LOS based on ATS and based on percent time spent following, and you take the worst among them. The worst. WOREST. E here is missing, sorry, est, worst. For this one here, a class 1, they are relying only on one parameter, which is BTSF. Only one parameter. And I will talk about how they differentiate between these three. I put it in a form of a table. The third one, which is the class 3, they are using the BFFS, which is a percent of the free flow speed. And this is a percent, by the way. Okay, and the percent time spent following also is percent, and the average travel speed, obviously, it's mile per hour, MI per hour. So how the HCM they define these three for us. They are saying that for a class 1, a facility, a 2-lane highway, is considered as a class 1 if the facility is high speed plus long distance. If the facility is described as a high speed facility and long distance, we classify it as a class 1. And all this written in my book at 2 different locations, in fact, okay, which is daily commuter, that daily route that is used by the people to go to work or deliver product or deliver whatever it is. These county roads that they are using, these county roads that come connecting facilities, connecting towns, connecting distribution centers, we consider them as a class 1. But class 2, they are low speed and short distance. But the low speed is a main important one. This is the 2-lane highways that leading to a lake, a scenic view. I'm going to Lake Tahoe, for example. So I am not really worried about the speed, but they are worried about the percent time spent following. And the percent time spent following, by the way, percent time spent following, they're saying that you are driving in one lane because we have only one lane. And assuming there is no passing lane. So you are here it is, Mr. Mansour driving very slow, and he has has a boat here, and you are driving behind this. So what's the percent, okay, of the time that you spend following this slow car? And they take this as a measure for the LOS. The third one, okay, so this is high speed, long distance, low speed, short distance. They are saying that for a class 3, that what will happen if the facility is going through an urban area, urban community. I believe they call it urban community, if I'm not mistaken. I will look at it. But going through a small community or a community in general. So they came up with this, and I believe small town development creation. Okay, here it is. So this is what the summary I extracted from the code about the classification of 2-lane highways. Class 1, class 2, and class 3. Class 1, it is long distance, okay, connecting facilities, daily commuter for routes that they are using, high speed. For the class 2, so this is long distance and speed and high speed. Okay. And this is why they are saying that there are 2 parameters, as you are going to see shortly in the table they provided to us. This class 2, they are saying that it is a 2-lane highway that generally serve relatively short trips. Motorists do not necessarily expect to travel at a high speed or high speeds. Examples, okay, route through rugged, okay, terrain, scenic or recreational routes. A route that is leading to a park or leading to a lake or anything. So right now they are saying that for this one, we're going to take BTSF only. Here, we are going to say that, oh, it is average travel speed plus BTSF. The class 3, it's still called 2-lane highways. This serving developed area, it could be class 1, class 2, that passes through a small town and so on. And this is a percent free flow speed, BFFS. The calculation of all these things are really not easy stuff. And equations after equations after equations, and tables after tables after tables. Maybe they will ask, I did not cover it when I talked about this during the class, if I remember correctly. I skipped it, but I went to the calculations for the LOS. If the ATS or PTSF or BFFS are given, probably I will go over how to calculate these things just in case. I can include some problems, I have no problem. But on the same page of my book, this is, by the way, on page 94 of I have my textbook. I'm always referring to my textbook. Okay. But if you have the original document, you'll find something like that, similar. Okay, as far as because I did not invent these things, I just reference. So the base conditions, we need to be familiar with that, and also the capacity for two-lane highways. Very important that they consider the 1700 passenger car per hour in one direction with a limit of 32 in both directions because of the interaction. They don't double this, they take only 3200. Okay. However, there are some situations that the double of the 1700 could be used. So per direction, they are saying that if this is 1700, let me write it down. At least you can refer to it. At least you can. So they are saying that per direction, it is per direction is 1700. This is a passenger car per hour. If this is here, so the other volume here must be 1500 only per hour. Because the sum, it is 3200 per hour. This is a capacity. This is a maximum capacity. Otherwise, you are in the F, LOSF. However, they said that we can go double of the 1700 if you have a tunnel or a bridge. If there is a bridge here, this is a bridge, or this is a tunnel, because tunnels and the bridges are expensive to construct. So they allow us to double the 1700. So, and this is what they provide us some kind of like exception, said that the two-way flow rate as high as 30 can be observed for a short segment fed by high demand. Okay, this is occur, for example, for tunnels and bridges. Examples for that. Okay, so those are the only two situations that we can double. But if you have 1700 in one direction, the 1500 must be in the opposite direction. After this, they provide us with a nice table. It does have all this in a form of numbers. And this is the LOS calculation for, this is a table that I need you to be aware of. The LOS for class 1, we have two measures. Class 1, we have ATS and BTSF. In class 2, we have only one measure, which is a BTSF. And the class 3, which is the percentage of the free flow speed, BFFS, sorry. Yeah, BFFS. Sorry, here, for this one here, we take the worst. Okay, class 1 is the worst. Here it is, the worst. If I remember correctly, I did include some problems in the mini exam number 2. And for example, problem number 17. Problem number 17 of mini exam number 2. A two-lane class 1 highway in a rolling terrain with an average travel speed is calculated to be 42. So ATS is given to be 42 mph. And the percent time spent following BTSF is given also. Oh, he's nice. 63%. And the facility has the following parameters. It does have lane width 12 feet, shoulder 6 feet, percent of no passing zone. Two direction flow rate is given 2800 passenger car per hour. Directional split 60-40. 10% trucks and buses and 6% RV, and the peak hour factor is 0.8. All this given to you to confuse you, except one piece of information, which is this one here. Two directional flow rate. We said that the code, the current code, said that if I have 1700 here, this must be 1500, such that the total should not exceed 3200. This is under the normal condition, except the bridges and tunnels. He gave me a direction split. What's direction split? One direction, we are using letter D also, by the way, unfortunately. One direction has 60% and one direction has 40%. This is what is meant. If the direction split is not given, the default will take it 50-50. 50%, 50% is the default for directional split. Here he gave it to be 60-40. Since I have the total two directional flow rate is 2800, I will take the 60% as a higher value of the 2800. This will give me how many passenger car per hour. Okay, so 2800 times 0.60. So 2800 enter 0.60 times, it's 1680 passenger car per hour. This is in the heavier direction. Let's assume this is heavier direction, which I indicate here. So the other direction is what? The difference between, which is a 40%, which is 2800 minus. So it is 1120 passenger car per hour. So I have, so I am below this because this is a maximum, 1680, and this is a maximum, and obviously 2800 is less than 3200, so I am not F yet. Because if you look to the table I was referring to, this table here, which is HCM table, highway capacity table, chapter 15, by the way. Chapter 15 is still the same chapter 15 as HCM 2010. This HCM 2016, okay, and the chapter is still the same, and they did not change even a single word in this chapter, the entire chapter, chapter 15, to the best of my knowledge. So this was a chapter among the few chapters left alone without any changes. I was trying to say F. F will exist if the demand exceeds capacity. So without calculating, we said that this here we call this is a capacity. capacity specified by the code, by HCM, this by HCM 2016. This is a capacity under normal conditions, excluding bridges and tunnels. Here, this is a demand. If the demand exceed the capacity, automatically I will select F. I don't have E and don't have F here. Would be a good idea to add F, but because it will be a useless problem if he gave you the demand and the demand exceed the capacity and you select F. So that this is an easy one, probably. But it will be a good idea to add F, just to add another answer that it may pay your attention. So the demand, input demand, is less than the capacity. So I am still away from F. So in this case, since this is a class 1, I will go to this famous table and I will do the following. I will say, okay, I have ATS. So bear ATS equals to 42 mph mile per hour. And this is a class 1, 42. Where is 42? 45. So 42 to 45. So 40 to 45. So I am at D, LOSD. But if I say bear BTSF, which is given to be 63%, okay, this will give me LOS what? Let us see. So 63%, so this is 50 to 65. So 63 is here. Okay, so the LOS is C. Will give me LOS of C. So I have C and D. And I have both answers, by the way, C and D here. But since this is class 1, I will pick the worst. LOS, the worst one. The worst. So that means that D is worse than C. So in this case, my answer is B as in boy. Make sense? Okay. The other parameters that given in the problem here, the lane width and the shoulder width and percentage nesting zone and the percentage of the trucks and buses and the RVs and the peak hour factor, they are giving just maybe to distract you, or they are no use. So sometimes they give you more than what is required, and we need to master. So look to the what is given, as I always say that look to what are the given information and what we are looking for. We need to understand what are the given information and what we are looking for, and the solution will follow, but we need to understand exactly what. Okay. I believe, if I'm not mistaken, I repeated the same problem. Yes. When I was doing this last night, I said, let me, problem number 20. It is the same problem. Did I change anything else? Forgive me because I can't. No. So I kept everything except this, class 2. So I kept the ATS to be 42 mile per hour. I left the percent times performance to be 63%. I left everything the same. This one here and this one here. I will check the same, check with it as far as the demand and the capacity. The demand less than the capacity. Okay, I needed to pay attention. Let me. I put less than. I didn't put equal, by the way. I didn't put because I was expecting maybe, or maybe some of you already will ask or already asked me before. What about if the demand equals to the capacity? I put equal sign here. Can I put equal sign? The answer is no. You cannot. Because when the demand exceeding the capacity, this will give you F automatically. And this is why the language they are using, demands exceed capacity, exceeds, not equal. Okay, so you have to be careful about that. Okay, so like the example I gave it to the class, and I think you still remember that my capacity, Mr. Mansour or Dr. Mansour, here we go, Mr. Mansour, here it is. His capacity is 100 pound. I can carry, this is my capacity. Capacity. The maximum load I can carry is 100 pound. Okay, without collapsing. This is a capacity. The demand, this is what, yeah, okay, you give me 50 pound. I can carry that. 70 pound. I can carry that without, you give me 99 pounds. I can carry that without collapsing because my capacity is 100 pound. If you give me 100 pound, I'm still able to carry the 100 pound without collapse. But so all this is less than the capacity or equal. But the moment you give me 101 pound, so the demand exceeding the capacity, and this is what Mr. Mansour will fail, collapse, unfortunately, and we have LOS of F. I need you to remember this. There is something called demand and capacity. We use this term a lot, or this terminology in design, especially in design for buildings, the demand and the capacity. The LRFD, if you remember the LRFD and strength design, we're using this a lot also. But it's a good analogy between the demand and the capacity for the transportation. So here, for this problem, problem number 20, all what I need, this is a class 2, as he indicated in the problem, so it's only one parameter, which is a PTSF. This is what they said. And bare BTSF, we decided based on 63% as given. Calculating, by the way, these things is really, really lengthy. The ATS and BTSF, if you look to the book, you will see that. Tons of equations and tons of tables. But if you look to the BTSF, and I will go to the same table, but this is a class 2 right now. So class 2, BTSF. So I have 63%. So I am here between 55 and 70, greater than 55. And okay, so this will go this way, will give me C. So LOS of C, and if I have a C, which is the answer D, and this will be my answer D. Make sense? So we need to pay attention to this, please, because I included some problems, by the way, related to um, uh, conceptual questions are important. Even if you, okay, which of the following are not parameters in calculate traffic density? D, which is the flow rate divided by S. And we need to pay attention. What are the parameters involved, and so on, so on, so. I include a problem number 13, okay, is related to do you remember HSO? HSO, which is a horizontal site offset. Horizontal site offset. HSO. There is a very nice equation, HSO, and we need to give you a scenario. The distance HSO, which is measured from where. Be careful what he is talking about, because the distance measured from the center line of the inside lane. Center line of the inside lane. We talked about that. I included a problem here. I included vertical clearance calculations. We already covered that, by the way. Okay, the speed for the distance. Okay, do you remember this distance? Because we need to make sure that the vertical clearance, okay, whatever the critical is, okay, probably he gave you the elevation here, so this will be the critical here. This, they call it C. In the code, we call it C, okay? And this is, I believe, in chapter 2, the horizontal design. Let me see if I still remember or not. Sometimes I say that, and sometimes, oh, the HSO is here, by the way. Here it is. The HSO, or the horizontal site distance, or horizontal site offset. Horizontal site offset, HSO. The HSO. So we need to pay attention to that. And the charts, already we talked about that. The C distance, to see if it is in chapter. Um, sorry, this is vertical curve. Sorry, it is here. Vertical design and vertical design. They call it C, and already we talked about that. And there are some equations. Let's see if I still remember or not. Let me see. Here we go. Yeah, here it is. So the code, let's go to the code and the green book. Here it is. This is the green book. This is the C. Here it is. This is in my book on page 286. 286. And so this is the C. And here are the equations, by the way. Okay, we talked about that and we solve problems. So here he is asking you, okay, because you know all the vertical curve information and you can calculate C, and from C you are going to work for backward, okay, to calculate S, and from S you are going to get the speed. So it's a very good problem. But he's asking what is the design speed. Design speed, speed S, okay, which is the not S, sorry, design speed V. Sorry, I'm S here is a side distance. Sorry, and S over there we just, I know S is the speed for the other code, but here is V, speed of V. Okay, you know exactly what the intention. I know V. Okay, not S. So you calculate S, the stopping side distance, and after that from the S we can get the V in this case. Okay, so it's a very good problem. Number 12. Go over it. I need you to do it. I need you to do it. A lot of problems I included just for refreshing your memory about engineering economics. Two problems. One is here, number 6, and one is here, which is number 11. So you have, in fact, this time it turned out to be there are 26 problems, not 25. Try to do your best. I know you are under stress, like anybody else, fear and stress. But I believe if we can use the time that has been given to us by postponing the exam, try to do your best. I know you have a family, you have relatives, you have, including myself. I'm not saying that. I have three kids away from house, one in Colorado, one in New York, and one in San Francisco here nearby, where they are completely locked. And the only thing that we can do is just pray and pray and pray and pray. And in addition to the prayer, obviously, uh, I will scan this immediately right now because I don't know if I will be back in the office. Because when I come to, I minimize my exposure going out, so I will scan it, and probably I will have something to eat, and after that, I will start seismic at 1 o'clock. If you are interested, here it is, the ID one more time. You can invite a friend or yourself if you like to join me seismic, uh, or if you like to sit and study for transportation, is your decision. Um, give it to a friend, give it to a neighbor, give it to anybody who is interested in seismic review for California, special seismic exam, the 2.5 hour, the 55 questions, which I'm sure that you will go over this after you finish the 8 hours for the national exam. And I will ask the webmaster if he can put it. Maybe I will send it to you when I scan this. I need to scan this right now before I forget, because and I will include also the. Oh, already I send you the sheet about this. I will do my best. I will do my best. Stay healthy and do your best, and we will keep working together, and hopefully that this crisis will be over very soon, and everybody is going back to the movie and studying for the PE, and enjoying the sun outside. But let us take all the necessary measures right now to be safe. And thank you very much for coming. And sorry yesterday that I was not able to make it, but I will find some time to take care of the AM and the construction group. Thank you very much. Always communicate with me, and I will do all my best to come back to you as soon as I can. And I wish the best to all of you. Bye bye.